Hello everyone, continuing our study of functions. This is the bridge for math. Often you'll be given a question that says find the domain of a given function. Now here today I've given you a quite ugly one. Beastie. If you don't like fractions, the other math F word besides functions, here's a fraction with another fraction inside of it. So there's really two fractions there. First fraction is 16 divided by the square root of 4x. And then the other fraction, the bigger one, is 1 divided by all of this. So a really evil looking function. So I want to break this down for you. There's really two real important rules for finding the domain of a function in algebra. So again, let's review. Function has a domain. The domain are the x inputs that work, that are valid. Typically, there's an infinite number of things that do work. What you're focused and curious about are which ones don't work. It's kind of like, hey, when someone asks you, hey, I'm kind of come over for dinner, and they say, well, do you have any allergies? You don't tell them the 5 trillion things you could eat. You can say, I love all food except, don't give me shellfish, I'm allergic. So likewise, these math algebra functions have some sort of, not happiness with certain x values that will not be part of the domain. So the two rules I want to emphasize is kind of like the 10 commandments, but here are the 2 commandments for domain. Commandment 1, thou shalt not divide by 0. And you know the truth, the only person who can divide by 0 is Chuck Norris. It's Chuck. So look at this, 5 over 0. Notice I got the cross as in do not go there, it's like bad. Number 2, thou shalt not take the square root of a negative final input. Again, square root of -7. Basically, functions are saying, I only want real numbers. And later on you'll discover what imaginary numbers are. Yes, there are imaginary numbers. And when you take the square root of a negative number, you don't get a real output. So that's not in the domain. So let's look at this particular function. Is there a situation where we could accidentally divide by 0? Should we be cautious and be paying attention? The answer is yes. Think about it. What if I put x is equal to 0 right here? What's 4 times 0? 0. What's the square root of 0? 0. Then you'd have 16 divided by 0. Boom! Bad times. I dare you. Triple dog, double dare you. Get your cheap calculator out and do 5 divided by 0. See what happens. After the explosion, you'll see probably an error statement, an E on your calculator. So right now, we found x equals 0 doesn't work. But that was the easy one. The true math ninja warlords get the second one. And I want to see if I can challenge you. Let's look at the bigger outside fraction. 1 divided by something minus 4. You see the minus 4 right here. My question to you is, what would this circle, what would that have to be to cause problems? 16 divided by the square root of 4x. What would this have to equal to cause problems? Yeah, good. If this were equal to 4, then subtract 4, you'd have 0 on the bottom, and that'd be bad news. So we have to be careful and find out what x input would result in this circled item being 4. Well, let's take it one step back. 16 divided by what would give me 4? Excellent. The answer is 4. Please don't turn your brain off. I know I've said 4 a lot, but just follow me. So 16 divided by 4 would equal 4. Okay. Well, how would I make square root of 4x equal to 4? Ah, very good. When x is equal to 4. Because what's 4 times 4? 16. What's the square root of 16? 4. What's 16 divided by 4? 4. And what's 4 minus 4? 0. And hence, if you look at the solution, x cannot equal 4 and x cannot equal 0. Those are bad. They're not in the domain. Are there any other things we need to pay attention to when it comes to domain per the 2 commandments? Well, I see a square root, don't I? Yeah, square root of 4x. So what do I know about 4x that's underneath the radical, underneath the square root sign? I know for a fact that 4x has got to be greater than 0. Well, then what is x? This is an inequality. I'll give you a quick review. If you want to get x alone, you just divide by 4 on both sides. What you do to the left, you better do to the right. If you're dividing by a positive, the good news is you don't change the direction of the inequality. You will only do that when you divide by a negative. So in this case, divide by 4, it cancels out. 0 divided by 4. Is 0 divided by 4 okay? Yeah, it's okay to have a 0 on top, just never on the bottom. So you have x is greater than 0. These are good. Any x value under the square root, any x input that's bigger than 0 will give you a positive input to that square root. So basically x greater than 0 is good. But x equal to 4, not so good. So let's kind of put this together. You have to put both pieces to get the final answer. Turns out the domain is all x such that x is greater than 0, we saw that, but x cannot equal 4. So what would this look like in terms of a picture, and what would a solution look like, mathematical solution? Let's draw a picture. Here's a number line, 0 in the middle, there's a 4. For x to be greater than 0, you just continue going to the right of 0. But what about at 4? What do we know about 4? That's another open circle. Open circle means that's not part of the answer. So 4 is not part of the answer. Teachers will ask you 2 ways to give a solution. One could be interval notation, which is kind of meaner, but if you draw the picture, it comes pretty sweet. If you look at the picture, what's the smallest thing to the left? 0. What's the biggest thing over here? To the right? 4. So 0, 4. This is not an ordered pair. This is interval notation from 0 to 4. Then you have this U for union, which means take this also. Anything bigger than 4, so anything from 4 to positive infinity. So that's interval notation for the domain. The domain is anything greater than 0 but not equal to 4. What's more intuitive? There's something called set notation. Set notation looks like it has these brackets, this little parentheses, x, this forward slash, x such that x is greater than 0 and x cannot equal 4. That's set notation for an answer. So I hope that helps you with finding a domain for a tricky function. This is the Bridge for Math, rooting for you for domination, and take care.